How's it going, guys? This is Miss Perry. I'm hearing that you guys are having trouble with naming the acids, so I want to go through this with you. I put this on RenWeb. If you do not have this worksheet with the notes, please go get it before I go through it with you. So stop the video and go get that, and then you can come back. Okay, so acids always have hydrogen in them because acids produce hydrogen ions. Okay? They always produce a hydrogen ion. That's how you know something is an acid. And acids are in two categories. You have binary and you have oxyacids. And those have hydrogen and oxygen and something else. But let's go with binary first. A binary acid has hydrogen and one other element. Okay, and here's some examples right here. And we're going to look at exactly how you're going to name those. So let's do one at a time. You've got, with a binary acid, you're going to write the root of the nonmetal, add the prefix hydro, and the ending is ic acid. Okay, so let's go through the examples. The examples are down here too, so let's go ahead and do both of these at once. It's the same thing that's up here. Okay, so let's just go through it one time. You can follow along on both of them, or either one you want. Okay, so HF is right here. You know that it's binary because it doesn't have oxygen. Okay, then you have, with a binary, you're going to put hydro in the front. And then the F is for fluorine. So you're going to put the root for fluorine, which is FLUOR. And then the end is going to be ic acid. Okay, and that's it. You're just going to name it hydrofluoric acid. Okay, so the fluor stands for fluorine, and the rest of it is the same because it's binary. Okay, let's do a couple more. You have HCl, which is also up here in the example. And HCl is going to be binary because it has hydrogen and one other element. And for binary, it's always hydro. Then you're going to put, you have chlorine, so it's going to be chlor, CHLOR, okay? Because you know that INE is a suffix, so you're going to take that part off. So it's going to be hydrochloric acid. Okay, so you're just following what it tells you up here. Okay, all right, let's do one that's not in the example. HBr is binary because it's just hydrogen and one other element. So let's put binary on this one. Then you have hydro because it's binary. And then bromine is Br, so it's BROM. And then ic acid. Okay, and that's how you do the binaries. All right, so let's go back up here and let's look at oxyacids now. They have hydrogen and oxygen and another element. So you're going to end up with a polyatomic ion. Okay, so it's going to be hydrogen and a polyatomic ion because you know it's O and something else. Okay, so we're going to write the name of the anion because your cation is going to be hydrogen. Okay, it's always hydrogen. So your anion is everything in the formula that's not hydrogen. And remember, you can look at the, oops, that's not it, the ion chart right here. And this has all the anions that you need. Okay, so when you start writing the formulas, you're going to need this to figure this out. Okay, so let's go back to the worksheet. And you're going to be writing the name of the anion without the ate or ite. Okay, and what that means is you've got, these have ate and ite on them. Sulfite, sulfide, sulfate. Okay, so you're going to look at those. So we're going to go back over here. And if the anion ends in ate, you're going to replace it with ick. If it ends in ite, you're replacing it with us. Okay, and then you can put acid at the end of it. All right, so when you have hydrogen and nitrite, you're going to have no hydrogen. You're not going to put hydrogen there. You're going to write the name of the anion. Okay, so it's nitric. So you're going to make it nitrous. Okay, I'm sorry, that's nitrite. So it's nitrous, because that's what this says up here. Okay, if it's HNO3, let me pull this back up for you. NO3 is, I'm lost. Okay, NO3 is nitrate right here. And NO2 is nitrite. Okay, so this is where you're looking to get the names. All right, so let's go back over here. HNO2 is nitrite, so it's nitrous. So we'll go from ite to us. HNO3, NO3 is nitrate, so it's going to go to nitric. So ate to ick. All right, so let's take one as an example. We know that these are oxoacids because they have oxygen. You might also see oxyacids. Okay, that's the same thing if you see it somewhere else. Okay, so we're not going to say hydro because there's a hydrogen there, but we're not going to say that. We're going to look at this SO4 right here. So let's get our chart. And SO4 is right here. And that's sulfate. Okay? That's sulfate. So let's look at that on here. 8 goes to ick. So that's going to be okay, that's going to be sulfur. So it's going to be sulfuric acid. And that one's a little weird, but it's because it's sulfur and it's sulfic. Okay, HNO3 is oxoacid. And you're going to look at NO3. And that's going to be over here somewhere. NO3 is nitrate, right there. You see it. Okay, nitrate is NO3. All right, so we're going to go back over here. And that's going to be, because it's nitrate, you're going to go to ick. 8 goes to ick. So it's going to be nitric acid. Okay, one more. This one is also an oxyacid. Because you have more than one, you've got this ion, this anion right here. So there's no hydro. We're going to look at the chart right here. And it's CO3 is what we're looking for. and that's carbonate. Okay, so you've got that 8 there. So that's carbonate. All right, so we know that it is carbon, but 8 goes to ic right here. So it's going to be carbonic acid. Okay, now I know those are a little bit of a stretch. We just have to practice them a little bit. Okay, so we're going to look at the ones down here, and we're going to work backwards. Okay, so the first thing you need to know is if it's binary or not, because that'll help you with it. If it's binary, it starts with hydro. Okay, so we know that it's binary because it's hydro. So we're going to put an H right there. And chloric is the same thing as chlorine, so it's going to be HCl. Okay? Now, I don't see any other binaries. The rest of them are oxoacids. So let's look at the next one. Nitrous. Okay, we still know there's an H. There's always an H, but you don't say it. And then you're looking at OUS. Let's go back up here. OUS comes from ite. Okay, OUS comes from ite. So we know that this is nitrite. So let's look at our chart and see where's nitrite. And that's right here. Okay, so that's nitrite NO2. All right, so let's go back over here and say NO2. Okay, and that's supposed to be a little one, but you guys know that. Okay, phosphoric acid, we know that it's oxacid because there's no hydro. So let's go ahead and put our H because it still goes. And ic comes from 8 up here. So that's going to be phosphate. Okay, because it was an ic. And now we're going to take it backwards to phosphate. Okay, so then let's look at over here and find phosphate. And it's right here. Okay, so phosphate is PO4. So we're going to go back over here and say PO4. Now, let me back up just a minute because I'm ignoring something that's important. Okay, on this one, the other one really isn't a problem, but let's look at this one. HPO4. Let's go back and look at our chart. PO4 has a -3 charge, and hydrogen is always +1. Okay, so that 3 is going to come down. Remember we did the crisscross? Okay, so that 3 is going to come down in front of the H. So it's actually going to be H3PO4. Okay, let me do this so it looks better. Okay, and that's the way it's supposed to look, huh? Okay, that's because you're matching up the ions. Okay, this is what you have already done in the past, but just in case you forgot. This one over here, HNO2, is okay. It was already matched up. Let's go back and look and make sure. Your hydrogen's always 1. Oops, that's anions. Your hydrogen's always 1. And then NO2 is always 1. Okay, so those matched up. You didn't have to do any suffixes there. Okay, so let's go back over here. We have sulfuric acid, and it has a hydrogen, even though you don't hear it because it's oxoacid. And then you have sulfur. So let's look at, we were ick. We're going to go back to 8. So we're looking for sulfate. So let's go over here and look for that. Sulfate is SO4, and it has a -2 charge. So we're going to go back over here, and that's going to have a 2 there because it has a -2 charge. And then SO4, was that right? Sulfate is SO4, yes. Okay, so it's going to be H2SO4. There you go. There. Okay, let's try one more. Phosphorus acid. Well, phosphorus sounds like you already have that, but let's look. For OUS, you're going back to ite. Okay, OUS goes back to ite. So we are looking for phosphite. So let's go over to our table. And there it is. Phosphite is PO3 with a -3 charge. Okay. So it's a PO3 with a -3 charge. So that's going to be PO3, but you have a -3 charge, so it's going to be a 3 over here, like that. Okay. Now I know that this is a lot, and you have, this is going back to when you were working with ions. So you may want to go back and look at your notes on that. Hope you didn't throw them away. But you're always going to be using ions, so you need to make sure you have them. But essentially, that's how to do it. Now, if you have questions, please let me know. There's also a chart over here that I'm going to download for you, or if you want to take a picture of it, that kind of says the same thing. Okay, and it's a little easier to see. So if you have 2 elements, that's binary, and you have hydro and then ic acid. If it's 3, it's oxyacid. There's no hydro, and then, whoops, I don't know where that came from. And it has the 8 and the ic and the ite and the os. Okay? So go ahead and try the other sheet that I'd already given you and see how that goes. The ones on the very end of that sheet are mixed. So that's just some ionic compounds practice. So those are not all acids. So don't let that confuse you. Okay, so message me if you have questions. Take it easy, guys. Bye.